Sets and Venn diagrams. A set is a collection of objects. Two sets are equal if they contain the same elements. Set A is a subset of set B if every element that is in set A is also in set B. The notation is A, and we have a sideways U with an underscore B. A proper subset occurs when every element in that set that is also in the other set and at least one element that's not in. It's like less than or equal to versus a less than. The union of two sets, written A, U, B, is a set of all elements that belong to either set A or set B or both. The intersection, which is written A upside down U, B, is the set of all elements that belong strictly to both set A and set B. If the intersection of two sets is empty, the empty set is denoted with this symbol, and then the sets are called disjoint or mutually exclusive when their intersection is the empty set. The complement of set A, which is written A superscript C, is a set of all elements that are in our universal set that are not in our given set A. For example, suppose we have the universal set of the numbers 1 through 10. Set A consists of the numbers 1, 2, 5, 6, 9, and 10. B consists of 3, 4, 7, and 8, and the set C consists of 2, 3, 8, 9, and 10. The complement of A would equal all the elements that are not in A that are in the universal set. This would consist of 3, 4, 7, and 8. A union C would be the set that contains elements in A or C or both. That would be the set 1, 2, 3, 5, 6, 8, 9, and 10. A intersect B consists of the elements that are strictly in A and B both. There are no such elements, so we could write an empty set like that or use our empty set notation. A complement intersects C. We're going to look at A complement that's up here in answer choice A and find what it has in common with C. That would consist of the elements 3 and 8. B union C complement would be everything that's not in the B union C. So let's find B union C first. That would consist of 2, 3, 4, 7, 8, 9, and 10. The values in the universal set that are not in here would be 1, 5, and 6. And last, A intersect B intersect C would be elements that are common to all three sets, and again, there are none. Venn diagrams can be used to represent sets. Each bubble represents a set. So suppose our first bubble represents set A and the second represents B. The shaded region right here in red would be A intersect B. In the second picture, we have everything in A shaded as well as everything in B and what they have in common. This would be A union B. The third picture shows almost all of A and none of B shaded and everything else around in the universal set. So everything that's shaded here does not include B. This is B complement. Last, this picture shows everything that's in A except for what's in B. This is B complement intersected with A. Let's shade some Venn diagrams. For A, I want to shade A complement intersect B. First, I'm going to shade A complement in yellow. Here's my A and here's my B. So everything that is not A, I'm going to shade in yellow. Now I'm going to intersect that with B. Now everything that's in B, I'm going to shade in green. Our answer consists of the values where these overlap. So everywhere that I have a yellow and a green shading would be my solution. So only the red represents A complement intersect B. For problem B, we want to do A union B and then get its complement. Well, A union B is everything that's in A and B and both. The complement is everything that I did not shade. So A union B complement would be this area out here that I'm shading in red. And last, I have three sets, A, B, and C. First, I'm going to shade what's in the parentheses, B intersects C. The place that B and C have values in common would be right here. Union that with A is all of this yellow and everything that's in A, which I'm going to shade in green. Both of these together make up my answer. So everything in here and here. We can also use Venn diagrams to represent numerical problems. Here we have a group of 100 people total, and their preferences of soft drinks are listed below. First, let's label our sets. We have three different kinds of drinks. We have Coke, we have Diet Coke, and we have Pepsi. Now, the best way to do these is to start with what everybody has in common. 5 people like all 3 soft drinks. All 3 soft drinks would be represented in this region right here. This is where all 3 of them overlap, so that would be 5 people. Now, let's find the other intersections. 15 people like Coke and Diet Coke. Coke and Diet Coke is everything in this region. Now I already have 5, so I need 10 more to make 15 to fill this up. 25 like Coke and Pepsi. Coke and Pepsi is this region right here. We already have 5 in that region, so we need 20 to make the 25 total. 5 only like Diet Coke and nothing else. That goes out here in the Diet Coke circle where it doesn't cross anything else. Now let's go back and see what else we can fill in. 55 total like Coke. Well, so far in the Coke I have 10, 5, and 20. That's 35. So that leaves 20 more in the only Coke region. 25 like Diet Coke total. Well, so far in Diet Coke we have 5, 10, and another 5. That adds up to 20, so we need 5 more right there. 45 people like Pepsi. 20 plus 5 plus 5 is 30 already in the Pepsi circle, so I need 15 more right there. Now if I add up all these numbers, 20 plus 10 plus 5 plus 20 plus 5, 5, and 15, that adds up to less than 100. In fact, we get 80. We had 100 people total, so that means that 20 didn't like anything.